Namaste everyone, welcome back to our channel. In the last video or the class, we have seen the how to solve the problems related to level curves and level surfaces, and we have solved many example and exercise. Now we are moving to the next concept, that is limits and differentiation. There is no much concept here. The concept that we have learned in the lower classes, that also in the simplified manner they have given. So our next concept is the limits. So what is this limits? How we can define these limits? So I will write the simple definition of limits. So I can simply define the limit as a limit of a function as a function f of x comma y approaches to the limit L as x comma y approaches to x naught or y naught. So we can simply write the notation for the limit. So how we are writing limit? Limit we are writing, this is the notation used to represent the limit as the value x comma y approaches to the another value, that is called as a limit. So we can write it is the limit of a function. You can the answer, if we substitute x comma y and if we replace x comma y with x naught y naught, what will be the value of the function? That is called as the limit of the function. So there is no complicated topic here. So I can say the limit of the function is, I can simply say that the value of the function's output as it approaches or get closest to the input x and gets closer and closer to the specific number. Here this notation represents that the x comma y approaching or getting closer and close to x naught and y naught. So this is the definition of the limits. Here we have some simple limit problems, so we will solve one by one. So this is our one example problems which can be asked in exam. So nothing is there, we need to replace x and y with 0 comma 1. Let us substitute and write the solution. Once we substitute the this value of the limit, we should not write the notation lim. Okay, so we are going to substitute that. Wherever x is there, we are substituting 0, and y is y, in place of y we are substituting 1. So it is the function 0 minus 0 into 1 plus 3 divided by x square. 0 square is 0, plus 5 into 0 into 1 minus 1 cube. So it will be 3 divided by, so minus 1, which is minus. This is the answer. Similarly the next problem, in this problem nothing is there, just we need to substitute that. So what will be the limit at this point? So 3 square, which is I'm writing 3 square plus minus 4 square, which is equal to square root of 9 plus minus 4 square is 16, so root 25, which is equal to 5. So this is our next example. While solving this kind of problems, now the problem arises. Here the value they have given both x and y approaching to 0 comma 0. So if we directly substitute 0 comma 0 to this function, so it leads to 0 by 0 form, okay, which is generally considered as the indeterminate form. So how to solve this kind of problem? So we are dealing with this kind of problem in our one of the unit that comes under in first sem. So we can solve this using limit using the L'Hopital's rule, but so here there is no concept of L'Hopital's rule. So we can make some of the rearrangement and we can try to solve this. So I cannot directly substitute, I need to make some rearrangement. So I will write the limit once again as it is, x comma y approaching to 0 comma 0, and the function also I am writing as it is. So I can multiply and divide to, in order to make some simplification and cancel out the terms, I will be multiplying with the conjugate of the denominator. So I can multiply and divide with the square root of x plus y and square root of x plus y. Can multiply and divide by this. So next we will see what will happen. So the limit x comma y tending to 0 comma 0, x square minus xy divided by square root of x minus square root of y. So if I multiply this, so here it will be square root of x plus y. It will be multiplied here also. So the denominator we know that a minus b into a into b, it will be square. So we know this formula, right? So a square minus b square equal to a plus b into a minus b. It is in that form, so we can write like this. So let us write one more step. X comma y tending to 0 comma 0, x square minus xy, so square root of I'm writing as it is, so it will be x minus y. The square of root x is x. So now I need to cancel or simplify this. So here I can take x common. What it will remain x minus y, then it will remain as it is, denominator x minus y. So this x minus y and this x minus y get cancels. So now it is simplified, so we won't get 0 comma 0 now. So what will be the function? X into root x into root y. Now if I substitute my limit, I will no longer be getting 0 by 0 form. So okay, when you substitute the limit, it will be 0 into 0 plus 0, so which is 0. So this is the answer. So this question is important, can be expected for party section, can be expected in party section. Now let us solve the exercise under this part. So this is the first question in exercise. There is no problem in substituting the limit. Here there are two terms, or the numbers are independent of x and y. If we substitute the limit, we won't be getting 0 by 0 form. So the first term will be 0 plus 0 plus 5. Here also 0 plus 0 plus 2. So the answer will be 5 by 2. This is the answer. This is our next problem in the exercise. Limit x comma y tending to 0 comma 4. The function is x divided by root y. Here also there is no problem in substituting the value of x and y. So here x approaching to 0 and y to root 4, which is obviously 0. This is the answer for the limit. So this is our third question in the exercise. So here also there is no problem in direct substituting the limit. So I can substitute here 3 square plus 4 square minus 1. So 3 square is 9 plus 16 minus 1. So it will be 9 plus 16 is 25 minus 1 is 24. So I can simplify and I can write. So 24 is nothing but 4 into 6. So the root 4 is 2. So I can write 2 root 6. It is the next question. So it looks little complicated, but it is very easy. So the limit x comma y approaching to 0 comma, it is ln 2 log to the base e, and the function is e to the power x minus y. Let us substitute the limits. So e to the power x here is 0 and minus ln 2. So 0 is not at all there. So e to the power minus ln 2. So here I can apply the log property, that is if it is something is number is there, means I can write log to the something is there, so I can write log. So it must something, my function must be there. So a log x can be written as log x to the power a. So here instead of a there is minus 1, so I can shift and I can write as in terms of power of 2. So I can write e to the power ln to the power minus 2. I can write here, sorry, it is not like that. So e to the power ln 2 to the power minus 1, I can write like this. So since ln and exponential inverse functions, so it will definitely be cancel out. So I can write e to the power minus 1, it get cancels out. So it is nothing but half. So this is the answer. So this is our next problem. Here we can see here the limit is not 0, but when we substitute that to the function, so it may also leads to the 0 by 0 form, which is once again the indeterminate form. To solve this we need to simplify by cancellation or anything. So but we can say the cancellation can be possible. There is one ready-made formula for this. So there is one formula, x cube minus y cube, which is nothing we can write in terms of x minus y. So x minus y into x square plus yx plus y square. So this is one of the formula for x cube minus y cube. So if I substitute this formula in the function, so x minus y and x minus y in the denominator get cancel out. So I will be applying this formula, or we can use any other step to simplify the numerator or denominator. So this formula is already there, so I can write x minus y into x square plus xy into x square divided by x minus y. So this get cancel out. Now I can substitute the limit values. So what it will be? It will be 1 square. X square is 1 square, which is 1. So 1 into 1 once again 1. So it is a y square. Okay, so y square, which is also 1. So the answer we are getting is 3. 3 is the value of this. So this is the last question under this parts. Here also we can see that when we directly substitute x and y, it will also leads to 0 by 0 form. So I have to do some rearrangements. So here I am writing the limit once again. So here I can the both terms y is common. I will just try. I will take y outside, so there it remains x minus y. Here I can take I will take minus 2 outside, so it will be x minus 1 it will be. So in denominator also there is x minus 1. From these two terms I can take x minus 1 common, so I will write that in next step, comma 1. So in these two terms I can take x minus 1 outside, so what it will remain? So y minus 2, it is divided by x minus 1. So this will be get cancelled. So now I can substitute my limits. So x comma y approaching to 1 comma 1. So here y is 1, so I can write 1 minus 2, which is nothing but minus 1. So this will be the answer. I hope this video is helpful to you and the method I did is understandable. If you have any doubt or any changes is needed, so please comment and tell. Thank you for watching. Please do subscribe.